Hello, let me bring to your attention a report approach to search result ranking based on users rating by Viacheslav Zosimov and Oleksandra Bulgakova. The ranking algorithm of search engines take into account a large number of factors, but the main weight is given to the page ranking, which is calculated based on the analysis of the quantity and quality of external links to the page. Such evaluation methods are objective, but they can be easily falsified with a certain advertising budget by purchasing the necessary amount of high-quality links from external sources. The main problem that this article addresses is development of a new approach to rank search results based on a user rating, which a subjective approach to the ranking process. The first paper presented on slide describes the learning-based ranking model, which is proposed to improve recommendation system which implicit users' feedback. In the second, a ranking model is described that uses adaptive learning to improve content-based recommendation system. The third develops a hybrid ranking model for scientific articles that combines content-based and citation-based methods. The ranking model using neural networks and weak supervision as described in the fourth. It can work with incomplete data, making it more universal and convenient to use. However, the drawback is the complexity of understanding the principles of neural network operation. The fifth is dedicated to use BERT, bidirectional encoder representation from transformers for ranking in search engines. Research results have shown that BERT provides high accuracy compared to traditional ranking methods. However, its implementation requires significant computational resources. In the real task of ranking search results, user ratings are used as input data for which their status as an expert is not defined. Obviously, accepting the opinions of all users who have rated the web resources as expert would be incorrect. However, this data is sufficient to determine subjective expert groups for each user based on the criterion of proximity of the user's rating to those of each expert. For convenience of presentation, experts are divided into three levels according to the method of calculating of their weight. The division into levels is only a logical nature. The weight of experts is taken into account when ranking search results without additional coefficients. Direct calculation can be applied in case the current user shares rating with a set of potential expert X for some set of web resources. It allows calculating the similarity of ratings for each pair of current user and potential expert D of U0 and UI separately. Expression 1 on slide. The quality of the connection is evaluated using the Shewhart chart. Candidates with high and very high connection strength are selected as experts. The weight of experts UI relative to the current user U0 is expedient to consider as a metric D in the metric space X and D, where X is the set of all system users. The function D satisfies the axioms of identity, symmetry, and triangle, but it cannot be defined for every pair of elements in the set X, since not all users have common ratings. Experts weight values are numbers within the interval from 0 to 0.9. Therefore, to determine a qualitative assessment, the result of a normalizing function is used rather than the value itself, expression 2 on slide. Forming expert groups only from those users who have common ratings with the current user significantly narrows down the circle of potential experts. To solve this problem, a method for calculating the weight of experts in the absence of common ratings with the current user has been proposed. It assumes the presence of common ratings with first-level experts and determines the overall weight of all potential second-level experts with respect to the current user, expression 1, taking into account their weight relative to the first-level expert, expression 2, and the weight of the first-level expert relative to the current user, expression 3. The weight of second-level experts relative to the current user is expedient to calculate as a product of the weight of the first-level expert relative to the second-level potential expert who has common ratings with the weight of the first-level expert relative to the current user, expression 4. The expert group includes second-level potential expert whose weight relative to the current user is more than 0.7. Formally, in the general case, the GIA algorithm for level R is defined as shown on slide. To build a model for calculating the weight of expert, a number of subjective features X, M were selected, which may directly or indirectly affect the visitor's evaluation. For modeling the degree of consensus among experts, a generalized iterative algorithm, GIA, of inductive modeling was chosen, which is polynomial network with active neurons. Figure 1 presents a system that takes an input X and uses it to generate different models on next layer R. The generated models are passed to an active neuron block that optimizes their complexity using combinatorial optimization and selects F best models. The final model is selected based on having the lowest error. Finally, the system outputs the value of Y. For comparing the results of the coherence of experts' opinions using the method described above, a data sample was used in which 20 users evaluated 20 web resources based on the quality of presented information and ease of use. For each potential expert paired with user 0, a measure of consensus of opinions was calculated. You can see it in table 1 on slide. To develop a methodology for considering the weight of second-level experts in ranking, it is necessary to choose criteria for assessing the ratio of the weight of second-level experts to the current user, expressed through the weight of first-level expert. Figure 2 and 3 shows the model of the differences in weight of second-level experts and their weight relative to the current user. The input data consisted of social profiles of users, U0 and to U60, who participated in previous experiments. Since their weight relative to the user 0 had already been calculated on the rating data samples, the same expert group were used for building the model. Table 2 shows the values of actual and modeled results on sample 8 and B for GIA algorithm. In figure 4, the generalized iterative algorithm reaches a minimum on the seventh layer. The proposed methodology is applied to the task of ranking search results in the search engine Google.com.ua. To verify the differences and correctness of the method presented above, 4 experiments were conducted. 4 data samples were formed, one for each experiment, from table 1 and 2. In each sample, 20 users rated 20 web resources based on the quality and ease of use. A total of 60 users were involved in forming the 4 samples. Some users participated in rating web resources in more than one sample. Each experiment involved several experts from the previous experiment and new users. This was done to be able to trace the weight values of the same experts in different data samples. The summarized results of the conducted experiments are presented in Table 3. The last row of the Table 3 shows the number of times the determined method provided in best ranking results. The resulting ranking model is much more difficult to falsify because it is based on subjective factors. Each user will be a unique ranking model, and falsifying it would require reproducing each user's preferences. Conclusions. An approach to ranking search results based on users' rating is proposed. The main differences of this method is the subjective approach to the ranking process. This effect is achieved by forming expert groups unique to each user. Experts are selected based on the degree of agreement with the current user, calculated based on the common ratings for a certain set of web resources. Selection of users for the expert group is based on their weight relative to the current user, which is a measure of their agreement. The proposed method had several advantages over traditional ranking methods. First, it takes into account a subjective nature of user preferences. Second, it allows for the formation of unique expert groups for each user, which can improve the accuracy of the ranking results. Third, it provides users with tools to manage their search results. The next step in the development of this approach could be to construct ranking models based on a large number of factors similar to modern search engines by incorporating additional factors such as click-through rates, time spent on a page, and other user behavior data. It may be possible to further improve the accuracy of the ranking results. Thank you for your attention.